Hi everyone, my name is Li Hao. Welcome to another day of Advent of Code 2020. So Advent of Code is a series of programming challenges on the Advent calendar. On every day on the calendar you have one programming challenge. Within the challenge you have two parts. Solving each of the parts gives you one gold star. And the goal of this challenge is to get all of the stars, which is 50 gold stars. So are you up for the challenge? Because today we're going to do day 24. 24? If this is the first time you're watching this video, which means you are losing out a lot, man. Let me tell you how much you have losing out. If you have missed day 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. You have lose out 23 videos. If you want to cash all of them out, please click here on the link on the top right corner. So we are going to do day 24 right now, and let's head up to look at our calendar. So calendar day 24. So day 24, lobby layout. Your raft makes it a tropical island. Makes it to the tropical island. So it turns out that the small crab was excellent navigator. You make your way to the resort. As you enter the lobby, you discover a small problem. The floor is being renovated and you can't even reach the check-in desk until they have finished installing a new tile floor. The tiles are hexagonal. They need to be rearranged in a hex grid with a very specific color pattern. Not in the mood to wait, you offer to help figure out the pattern. The tiles are all white on one side and black on the other, so they start with the white side facing up, and the lobby is large enough to fit whatever pattern might need to be appear here. So it's an infinite lobby space. Okay. A member of the renovation crew gives you a list of the tiles that needs to be flipped over, which is your puzzle input. And each line in the list identifies a single tile that needs to be flipped by giving a series of steps starting from the reference tile. In the very center of the room, well, every line starts from the same reference tile. Because of the tiles are hexagonal, every tile has 6 neighbors: east, southwest, southeast, west, northwest, and northeast. Right? So I'm gonna draw it out here, which means that you have 6 neighbors. You have east, southeast, southwest, west, northwest, northeast. Right? So 6 sides. So tiles are gonna rearrange this way. Okay, pardon for my drawing. Oh wait. Redraw them. Okay, so gonna. Whoops. Hold on a sec. Find. How do I draw this? Shit. Okay. Let's see. Show screen brush. Okay, got my brush tool up. Use the drawing. Okay, so I'm gonna draw it out again. So I have 1, 2, 3, 4, 5, 6. And this is the same, 3, 4, 6. And this is like this. Right, so this will be the tiles. I draw a few more lines over here so that it will be helpful later on. Right, so this. Right, so yeah, so this 6 directions, right? Right, east, southeast, southwest, west, northeast, and northwest. Right. So a tile is identified by a series of directions with no delimiters. So for example, ESENEE identifies a tile that you land on a reference tile, move one tile east, one east, northeast, and east. Right. So okay, so probably we'll look into that later on. So each tile is identified, it flips from white to black or black to white. Tiles may be flipped more than once. For example, a line like ESEW flips the tile immediately adjacent to the reference tile, and a line like this flips the reference tile itself, right? So we're gonna look at this one. So northwest, right? Northwest and then west, right? So northwest will be here. Oops. Let's say here. and then west will be here, right? And then southwest will be here, and then east and east, right? So this is east, this is east. So we're back to the reference tile, right? That's why I need to draw so many tiles, because this is yeah, you can move a lot of angles over here. So I'm gonna do all this, and let's go back. So here is a larger example. So in the above example, 10 tiles are flipped once and 5 more are flipped twice. So after all that, after all the instructions have been followed, we have a total of 10 tiles that are black. So go through each of the renovation crews list and determine which tiles they need to flip. And after all the instructions that have been followed, find out how many tiles are left with the black side up. Right, so we're gonna get our puzzle input. We're gonna save it into the input.txt file. And we are going to, okay, so we're gonna clear this. We're gonna copy the file on day 24, code day 24. Okay, and I'm gonna, as usual, we're gonna read out the file with files fs from the Node.js module. So read file sync day24.txt and UTF-8. Right, so let's take a look at the day 24. Sorry, day 24. So you're gonna look through all the lines and then find each of them, what the tiles are they, right? So we're gonna split lines equals to content.line split by new line. So I'll call them instructions, right? So these are instructions to flip. I'm gonna have another thing, which is a set of black tiles, which is a set. So every time when we flip from black to white, if it's white to black, then we'll add it to the set. And if we flip it again, we'll just remove it from a set. So this set will contain the black tiles, right? And the goal of this is to console out, to find out how many tiles are in the black, right? So the answer in the end will be the size of the black tiles set. Right, so we're gonna look through instructions, which is for each instruction. I'm gonna find a tile to be flipped. Get tile. And then if the tile is so if it's in a black tiles, then black tiles dot remove it, or else we're gonna add it, right? Black tiles dot add tile. Okay, so now what we're gonna do is we're gonna focus on how do we get the tile, right? Which is in this function, get tile instruction. So we're gonna move from one character one at a time. So let I goes to 0 while I less than instruction that length. I'm gonna do something, right? So okay, so and we're gonna switch instruction I, and then probably we'll have either, so it's either starting with east, southeast, southwest, west, northwest, and northeast. So it's either E, S, W, or N for the first character. And then if it's S or west, north or south, then we're gonna have the next character. Right? So we're gonna switch from case east, west, north, east, and northwest, south and north, south, east and southwest, northeast and northwest. Okay, so we're gonna do something over here. Right, so now the next thing is how do we represent the tiles? Right, so we're gonna come out over here again. Sorry, let's show screen brush. How do you show? Oh, so here's this. So I'm gonna label it here, right? So we're gonna have so from the reference, so this will be the reference tile. Probably will start from 0, 0, right? So what this means is that I'm gonna say row is 0 and then probably something like a column with its second number, right? So we're gonna try to label all of them. So this will be 0. So I'm gonna say x and y first, right? So this will be 1, 0, and probably this will be negative 1, 0. Negative 1, 0. How do I move this? But never mind. Oh yeah. Okay. And then so this one, so whether this is 0, okay, so most likely it'll be 1, right? So I'm going to say 1 moving down and negative 1 on top. But whether this is 0 or 1, 1, 0, 1 or 1, 1, right? I think we can decide on our own. We just make sure that it is consistent. So I'm going to say 0, 1 in this case. So which means that this would be negative 1, 1, right? So over here, when we move on top, what should we call this, right? So we can call it, so probably we just do it like a sloping upwards thing. So this will be 1, negative 1. So 0, negative 1, and then here will be negative 1, negative 1. Right, so which means that when we go up over here, so it's rather go in this direction, it's gonna be 0, 0, 0 all the way, right? Here is negative 1, negative 1, negative 1 all the way. Right, so here would be, yeah, so negative 1, right? Let's see. Yeah, I think we can define it this way. Then, so we're gonna have two numbers to represent it. So we're gonna say we'll call it x and y for now, and it will both starts at 0. And let's look at our instructions, right? So if we are moving to the east, which means this direction, then we're gonna increment the x value, right? So x plus plus break, and west will be y minus minus, and then break. Right. In both cases, we also will have. Wait, never mind. I think in the end we will have the plus plus, right? How about I'll just do it here. Y plus plus for here, because we're going to have one character, and here is like I plus equals 2 because 2 characters. For norths, when you begin with north and south, it could be northeast, northwest, southeast, southwest, right? Yeah. So next, if it's north or south, we're gonna look at the next character, which is instruction I plus 1. If it's equals to east, else then probably it's equals to west, right? I'm gonna copy. So north. So let's see. If it's moving north, east, or west, it will definitely always be y minus 1, right? So I'm gonna be y. So we're gonna say y minus minus. So if it's south will be y plus 1. Right. And then if it's east, north east, which is this direction, northeast, then my x position will also plus 1. Right? Position plus 1. And if it's northwest, then the x position northwest does nothing. Okay, so we're gonna keep it like this. So for south, let's see. So the south will be only for the southwest that will be minus 1. X minus. Right. Hopefully we have this. Yep. And then the tau, what we're gonna return is the coordinates, right? So it's x and y coordinate. Right, and I think that will be it. So let's take a look at, let's run this. 24. Hold on. Remove. Oh, okay. It's not remove, it's called delete. 154. Hopefully that will be the right answer, and let's paste it in, and that is not the right answer. Man, okay, so let's come back and take a look at what went wrong. Okay, so let's see. Let's just try this. Okay, let's just try this and see what is the tau value. Right. So come here. Okay, this gives me 1 and 0, which is incorrect, because I should go back to the reference tau itself. Right, so I'm gonna see what went wrong over here. Okay, I think I know why, because I didn't break over here. So I'm gonna break. Just move this out so that it looks consistent, and let's run this again. Wait, no. I'm still at 1, 0, which is incorrect. Let's see. Okay, so let's go through step by step. I'm gonna console log X and Y on every instruction, right? Clear, and gonna run this again. So I'm gonna move. Let's see. Okay, so I'm gonna open it over here, and this is gonna be over here. And look at our graph. So I'm gonna move northwest. Remove all the arrows. Okay, northwest. From a reference, northwest a bit here, right? So we're 0 and -1, which makes sense. And then west, so we're gonna move from here, -1, which is correct as well. I'm not sure you can see it, so probably I'm gonna hide it somewhere. Okay, I'm gonna open it over in this lower left corner. Okay, so -1 is correct. And then west, and then southwest, which is here, right? It's something that we haven't drew. Which I'm gonna draw it out now. And this should be -2 and 0. Right? But we get -1 and 0. Right? Southwest, which is incorrect. Right? So this is something probably we need to fix. So it's a southwest instruction that is not correct. So south, let's look at south. Oh, okay, this one, west. Okay, I think I got it now. So southwest is the, so we got 0 and 1, which is correct. So now we're gonna come back over here and gonna copy this example input, and let's take a look. 10 tiles, which is correct. So hopefully we can remove all the console, so it's easier for us to read now. Okay, and we're gonna copy the input text over here. Let's run this. And 488, which now looks, I'm not sure, is it promising? Let's see. 488, and that's the right answer, and that we have 1 gold star for part 1. And let's move on to part 2. So part 2, the tiles floor in the lobby is meant to be a living art exhibition. Every day the tiles are flipped according to the following rules. Any black tile with 0 or more tiles, more than 2 black tiles immediately adjacent it, is to be flipped to white. Then white tile exactly 2 black tiles immediately adjacent to it is flipped to black. Right, so here tiles immediately adjacent means 6 tiles directly touching the tiles in question. The rules are applied simultaneously to every tile put another way, it's first determine which tiles needs to be flipped, and then they're all flipped at the same time. Right. In a given number, the number of black tiles that are facing up after the given number of days has passed is as follows. So after executing this process a total of 100 times, there would be a 2,208 black tiles facing up. So how many tiles will be black after 100 days? Right. So I think we started with 10, and then after day 1 it becomes 15 because of this flipping rules. So we are going to come back again over here. So once we are done with this, done of going through the instruction, we are going to loop through 100 days of flipping. Less than 100 day plus plus. Okay, over here. Okay, so let me send to this. So now we're gonna look through all the day and we're going to do the flipping, right? So black tiles is now like a set that we play with. So we're gonna say next black Okay, I'm gonna call like black tiles equals to flip black tiles. So in this function, we're gonna return a new tile sets, and after at the end of 100 days, then we are going to log out the length, the size of the black tiles, which is number of tiles that are black. So we're gonna fill up this flip function. Right. Let's see. Let's do it here first, right? So first of all, we need to know we'll look at all the black tiles and also the white tiles, right? So probably we will have somewhere that starting point and ending point for us to do a loop. Loop through all of the tiles and then find all the neighboring tiles, and then determine whether they are okay. So probably I'm gonna have something over here like let's min x, let's max x, let's min y, and let's max y, right? So this is something I'll determine later on. But assuming they are numbers, what we're gonna do here is that we're gonna loop from min x all the way to x to max x, and do the same thing for y as well, max y. So we have a tile called x and y, and we're going to determine the neighbors of it, right, and determine whether we should flip it or not, right? So neighbor equals to get neighbor x and y and the tiles, right? And if so if the current black tiles dots okay, so we're gonna have the next tiles, right? Next black tiles over here. So probably I'm not gonna do the flip thing, the remove here, and this is gonna be this, right? Next black tiles, and then black tiles assign it back, right? So if this tile if this tile is black, which means that black tiles have it, I'm gonna follow the black rules, which is with a black tile, 0 or more than 2 black tiles immediately adjacent to it, then it is flipped to white, right? Which means that if it has 1 or 2 black tiles as a neighbor, it will remain as black, right? So if neighbor is 1, on neighbor is 2, then next black tiles will have this tile. Okay, I think I will probably write this quite often. I'm gonna say let's call it tile. Okay, so if it is not black, then it's white, which means that exactly 2 tiles only flip to black, right? So if neighbor is exactly 2, then next black tile will add this tile, right? So we can collapse this, right? So that will give us what are the next black tiles, okay? So once we find the black tiles, right, at the same time we also probably might need to adjust the min and max x, because like for example this is black tile, then if this is a new black tile, then on the leftmost, then let me draw it out here. If this is like the newest black tiles on the rightmost, then probably we need to increment the max y to be include like 2, 0, right? So if this is a black tile, if the next tile is black tile, then probably we're gonna do over here. So instead of doing both places, let's collapse this, right? So if it's black tiles, then we have this condition, right? So if it's black tile, then we have this condition. If it's a white tile, we have this condition. Oops, sorry. So this is the condition that I will have to add the next black tiles. Collapse all this in over here. Okay, so here we're gonna add our min and max. We're gonna adjust it. So min x equals to math min x and min x minus 1. Okay, so we're gonna this as well, y minus 1, and then x plus 1. This is y plus 1, y, right? So min x equals to x minus 1, minimum of x minus 1 and min yx. Max x is this, min y and max y, right? So we just need to find out the initial min x and min max of x and min max of y, which we can do by looping through the black tiles. So we're gonna say tile of so over here the tiles are actually in a string which comma separated. So we're gonna say let's x y equals to tile dot split by a comma dot map number. I'm gonna copy this again over here. Okay, and that's it. And let's try run this. Let's try run this. Probably run it with, just to be safe, run it with this inputs over here. Right, let's see. Oh, what? Tiles. Okay, so tiles. Okay, neighbor. We didn't have neighbor function at all. Okay, but even that, let's see. Console log min x max x min y max y. I think because initially they are all okay. Then this will be it. I also need to define get neighbors. Totally forgot about it. Number of neighbors, right? Function get neighbor. I'm gonna have black tiles x and y. Right. So how do we determine neighbors? Right. So we have probably can look through different kind of x and y coordinates. Which is okay. Let's look at this again. So -1. So 0, -1. -1 on the x, y. Okay, so let's write them out one by one. This one is -1 on the y, right? So -1 on the, this is like delta from the reference tile. So this is x, okay, so -1 on the y, +1 on the x, -1 on the y, +1 on the y, and then -1 on the x, -1 on x, -1 on the x, and +1 on the y. 0, 1. And lastly, 1, 0. Right, these are the neighboring cells difference. So we're gonna say if the count number of tiles, right? So we're gonna have count equals, starts with 0. And I'm gonna return this count. So if black tiles has x plus dx and y plus dy, counts plus. Right, and let's run this. 2208, which is the same answer from the example. So let's, the moment of truth. Let's copy this input and let's paste it in. And let's run this, and voila, 4118. Gonna paste this in and submit. That's the right answer. So we have solved day 24. If you like this video, please give me a thumbs up. If you feel that there's something I can improve on, comments down below. And this is day 24, guys and girls. We left with one day, and that will be on the next video. So if you want to know when that's out, please be sure to subscribe to my channel, which is on either side. I believe it's on this side, or on below there's a subscribe button. Click that so you know when the next video is out. And see ya, bye bye.